Here we are again. Here we go. As promised, we're going to do cyclic alkanes next, and we're going to name them. This is a 5-carbon ring here, 5 carbons. It starts with the prefix CYCLO and ends with the name of a 5-carbon chain. Let's remind ourselves what pentane looked like. And remember, pentane had extra H's on the end. If you want to make a ring, you're going to have to get rid of those H's and put them in a ring where every carbon has 2 H's. So to make ring, you must lose these 2 H's. And you have cyclopentane, which is C5H. Let's do it like this. It started out as pentane, and then because it's got a ring, C5H10. Okay. And that was right here. Losing the 2 H's. Okay, this next molecule is also a cyclic molecule. It's got 6 carbons in the ring, hexane, and it's got a group on it. I believe it's a butyl group. 1, 2, 3, 4. So you just say butyl cyclohexane. And some of you are probably asking, hey, last time he had a group on there, he had to put a number in front of the group. I say to you, you're correct. But when you have a ring, you can number any carbon number 1 that you want. And when there's only one group on there, it's understood it has to be on carbon 1. So if you put a 1 in front, it's redundant. I won't take points off, but I'll tell you who the picky grader is on the nomenclature. It's OWL. So if you put a number in front of that, it'll probably just tell you you're wrong. Our next example, though, we're going to need numbers because there's more than one group. It's a cyclobutane because it's got a 4-carbon ring. And it's got 2 ways of numbering. If we chose this to be 1, we would go here for 2. I like that a little bit better than starting here, going to 2 here, and here's the reasoning. What I'm going to do is in red, put the number where the first group is, which is 1. Put the number where the second group is, which is also on 1, and put the number where the third group is. Now, if I'm using the blue system, the first group is on 1, second group's on 2, and the third group's also on 2. So when there's a tie on the first number, and I could have had this discussion earlier with our normal acyclic molecules, if there's a tie on the first number, you move to the second number to break the tie. And I think it's understood if those were still tied, you'd have to go to the third number, but they're not tied. So the red system is superior in this example. It has ethyl groups on 1 and 2. And why am I putting the ethyl groups first? Because they're starting with the letter E. And the methyl's on 1. A little nervous about fitting it in there. There you go. Didn't fit, did it? Think small. There, close enough. Good. So there you have it. Now, there's something called geometry. When we do Wednesday's lecture, we're going to talk about something called conformations. And you want to read about that before Wednesday. And when we have structures that don't have rings in it, all the bonds are freely rotating in space around each other. So if a methyl group was pointing up in the first conformation, after some rotations, it might be pointing down. With rings, though, they're a little more rigid. They don't have complete rotation. So if two groups start on one side of the ring and then you do some rotation of bonds, they'll still be on the same side of the ring in both conformations. Read about conformations. Right now, you have no idea what I might have just said. When we have two groups on a ring that are on different carbons, they're either on the same side of the ring, in which case we're going to throw this prefix in front of the name, cis. And when there's two groups on opposite sides on different carbons, it's trans. So let's do some cis-trans examples. This is where we're going to have to use wedges and dashes again. So if I have a ring, we haven't done a 7 yet. And we haven't done a 3 yet. And on this first example, if I had, say, sticking out of the page, a big old bromine, and going in behind the page, an isobutyl group, it would start with cis. And now we have a small issue. Notice the red-blue numbering system here and how I broke ties. You will not be able to break the tie with the same system down here, because if you choose the red system, it's a group on 1 and a group on 3. If I choose the baby blue, it's also a group on 1 and a group on 3. The good people at UPAC have a rule to break that tie, and I'm not making you responsible for it. So I'm not even going to talk about it. I would accept the red numbering and the blue numbering for full credit here, and I'll stick with the red. There's a bromo on 1. BR goes before, oh, yeah, BR goes before I. Why did I say I? Bromo. And then 3. ISO. That's why I said I. ISO with 4 carbons. If you see one of those patterns, try to use the common name. See the V on the end? You should try to use the ISO naming system. And it's a cycloheptane. And I said cis, huh? I'm fired. Cis is for when they're on the same side of the ring. This is trans. I don't know how to fix that. I do. Started on the wrong foot there. Hello? We'll do trans first, then cis. Try to shrink it a little. No, trans big is fine. All right, and 1's sticking out of the page on the opposite side of the ring as the dash, which is behind the page. Cis, you can have wedge, wedge, or dash, dash. Wedge, wedge, meaning they're both sticking out of the page. And I don't know. And cis means the other one is also sticking out of the page. And this was for this name. And we'll go with this name down here. This is a sec 1, 2, 3, 4, 5 sec pentyl. Goes by P. Remember, the sec doesn't count. F is before P. So our second example, cis. Numbering, you can go 1, 2, or 1, 2 the other way. It does not matter. To me. To UPAC. UPAC's going to say the red's better than the blue for reasons I don't want to get into, because then I've taught the reason before, and then students forget more important nomenclature rules, and they start getting confused. So I'm just going to stick with the sec pentyl on 1 and the fluoro on 2, which means fluoro's first. I don't put a 1 there, I put a 2, and it's a fluoro. And 2 has a sec, 1 has a sec pentyl, if I'm using the red system. And how do you say ring size 3? Well, you start with cyclo, don't forget that. And you put propane. So we'll just finish this short segment with something that's got a big ring, just for fun. One big old ring. Yeah, that didn't work out very well. We'll make it work out. Doesn't have to be pretty. Looks like it's got a little mouth over there. And then we'll put groups on. Well, let's do a funny one. Oh, the group is a ring. Wow. And then right away, I know this, what cis or trans. Let's see, one's a wedge, one's a dash. That's trans. And I'll put something where we have to use our systematic naming. And we'll put like a, there. And have we used BR or CL? Don't know yet. Okay. Let's see. Starting with trans. Now, if you go 1 for this carbon, you shouldn't go this way. You won't get the next group for a long time. If you go 1 here, you should go clockwise. 2, 3, 4. 2, 3, 4, 5. And this name is, you got to use the systematic name where the 1, 2, 3, 4, 5 carbon names, pentyls, preceded by both bromo and chloro in the name. That's going first. So I think on this one, it would help if we have an unmarked version to know where we started. Okay. And we'll get rid of the part of the answer there. And we'll pretend we didn't know the numbering. And once again, the other direction would have been fine, going 1 down here, 2, 3, 4, 5. You still get 1 and 5. So we're at trans. The one with the bromo is going to go before the one with the, yes, the group has a C in this first letter because the group's cyclo, and that prefix counts. You know how I know it counts, the cyclo prefix? Because it's not on my list of things that don't count. That list will not grow. Okay, so B before C. Don't forget, you need parentheses for a group that has groups on it. This is carbon 2 of the group that has the groups on it. 2-bromo goes before chloro alphabetically. Chloro, and it's a pentyl group. And you were going to mention to me what I forgot. You got to tell me where the group's attached to the ring. That's carbon 1. And then carbon 5 has a cyclobutyl group on it. Yes, it's a group. How did you name groups before? You changed ane to ill. That's the same system, isn't it? And then how big is this ring? Well, we got 5. There's a carbon there, 6. It's a little messy here. I did not want that to look like an extra carbon. Let's make sure it's not a carbon sticking off. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How do you say a 15 carbon ring? Quite simply, you say cyclo, because it's a ring, and some prefix before decane that says 5. Cyclopentadecane. Why is it trans? One of the groups is a dash, one's a wedge. When do we have cis? When they're both wedges. I will redraw that molecule just to show you. You can also have cis with double dash. And we got this dash, methyl, and dash with a terrible looking F. And that will close our segment, and we're going to come back with bicycles. Strangely, we're learning how to draw a unicycle, which is these molecules, before bicycles. I do not suggest you learn how to ride a unicycle before a bicycle. And that concludes this segment, and we'll see you in 5. Oops, I did that wrong. Don't talk and do stuff like that at the same time. All right, see you soon.